Hey geometry students, here is your review for Unit 5. Starting with learning target 1, find or use the triangle midsegment theorem to write an equation and solve for x, and then go back and find the length of AB. Well, here you got the midsegment, and here you've got the base. The one thing that you got to remember is to make these two things equal, you would have to double the midsegment. And so that's why here you see 3x plus 1 times 2. Use the distributive property to make that 6x plus 2. Now you can make that equal to the base. Go ahead and do the regular stuff to solve for x, and you wind up with 6. Go ahead and plug that back in to find your midsegment, AB. 3 times 6 is 18, plus 1 is 19. All right, here you've got, I guess I have two options I could give you. One, I could ask you to prove that the distance of the midsegment is half of the base, like we saw in Learning Target 1, or I could ask you to prove that they are parallel. In this case, obviously, I asked you to prove that the distance is half the base, and if I ask you to find that the distance is half the base, well, you're going to have to use the distance formula to find those distances. Now, you weren't given the midpoints here, although you could probably just look and see what they were. Or if that was difficult for you, you could use the midpoint formula. I just looked at them and saw that this was 5, 3, and 6, 6. And so if I want to find the distance of AB, the base, well, here you can see I've set up the distance formula. Subtract the y's squared, subtract the x's squared, and you wind up with about 6.32. You do the same process for the midsegment. Subtract the y's, square it, plus subtract the x's, squared, take this whole square root, and you get 3.16, which turns out to be exactly half of the base. And so make sure that you're showing all of your work and that you very clearly show that the midsegment is half the base. Some of you, you kind of had some answers like this, but man, you definitely didn't show your work in a clear, logical manner, so I couldn't give you a 5 there. All right, let's see. Learning target 3. Use the perpendicular bisector theorem or the angle bisector theorem to write and solve equation for x. So you got a case of both of those here. Here you've got the perpendicular bisector, which means you know that these two segments are congruent. So you just set them equal to each other, solve for x, plug that back in to find the length of AB, and here you get x is 9 and AB is 60. This one, the math is the same, but you just have a slightly different scenario. Here you got the angle bisector. You can tell that by these two lines right here. And you also know that these are perpendicular, which is what makes these two things congruent. So you set them equal to each other. Over here you do the distributive property. That makes for negative 2 plus 14x. And then again, you do the regular stuff here, subtract 5x, add 2, and you can wind up with x equals 4. Plug that back in, and you find that AB is 54. Okay, moving on to your proof. This is the proof of the perpendicular bisector theorems. You had the two. You had the angle bisector and the perpendicular bisector theorem to prove. Here you are given that AC is the perpendicular bisector of BD, so you needed to prove that AB was congruent to AD. Well, obviously we've got the given, and then we say that angle 1 and angle 2 are right angles. Not that they're not, they are congruent, but that's not what we're trying to get at right now. We're trying to get at the fact that they're right triangles, so I can use a right triangle proof. So the first thing I do is I say that angle 1 and angle 2 are right angles by the definition of perpendicular. That's given to us right here. And that allows us to say that the triangles are right triangles. Now that I've got that taken care of, I have clearly stated that they're right triangles. I can go ahead and say that BC is congruent to DC, and that's by the definition of bisector, not angle bisector, just bisector. It's perpendicular bisector. That means these two things are congruent. And then AC is congruent to AC. That's by reflexive, of course. And because this is a leg and this is a leg, of course, the hypotenuse is over here. That's opposite the right angle. Neither one of these things that I have are a hypotenuse. And so I have leg, leg. And of course, because these are congruent now, I can use CP/CTC to show that the corresponding parts, including AB and AD, are congruent. Okay, moving on to circumcenter, in-center stuff. It says write an equation and solve for x. So here we have angle bisectors, and that makes for this point here, A, to be the in-center. And, well, the in-center, all the perpendicular lines from the in-center to the sides are going to be congruent. That's something that we saw clearly this year. That's why we can draw the inscribed circle. Well, it turns out that these are just congruent things. And so it's another case where we set things equal to each other, solve for x, you get x equals 1, plug that back in, you get 8. All right, you all have access to all of the construction instructions, so if you want to do well on this one, I'd practice it. I'd watch that video if you needed to. There's two that I'm asking you to be able to do, the inscribed circle and the circumscribed circle. So know how to do both. This is kind of what the in-center should look like with the angle bisectors. And of course, the circumscribed circle, you'd have the circumcenter, and then you would connect the dots on the outside. Here on page 2, we start with learning target 7, finding the coordinates of the orthocenter for the given triangle. So, typically what will happen here is you'll have a triangle where one of the sides is either vertical or horizontal, and that'll make one of the altitudes, which is the distance from one vertex perpendicular to the opposite side. That'll be pretty easy to find. In this case, this altitude was the easy one to draw. The other one, well, not so much, because you'll have some sort of slope. Now, you could probably freehand it and get a pretty close estimate. If that's what you do, I'm willing to give you a 4 out of 5. But if you want to get a 5 out of 5, you need to kind of show all of this process here in order to get that orthocenter and this line. So if you chose to find the line perpendicular to CE that went through B, the stuff in red here is what you would do. First, you would find the slope of CE, which is -3. You go down 3 to the right 1. And then the slope of my line perpendicular to that would be the negative inverse. So the negative inverse of -3 is positive 1/3. You use that to find your new equation. So I got y equals 1/3 x plus b. I need an x and a y. Well, the x and the y are going to come from this point that I wanted to go through, and that's 4, 6. So I plug in 4 for x and 6 for y, and I wind up getting 4/3. And so if I subtract 4/3 from 6, I get 4 2/3, which means the equation for this line, that's the altitude that's perpendicular to this, that goes through B.
Chorale and a cappella students may be dismissed to go to the Jubilee. Thank you.
Which gives me a y-intercept of 4 2/3, which would be right about here, and a slope of 1/3, so up 1 to the right 3, you'd be right about there. And you can see that's pretty close to what you would freehand anyway. The place where these two lines cross is my orthocenter, and it looks like it crosses right here at 1, 5. Now, if you chose to make the line perpendicular to EB that goes through C, you probably had a lot easier time. So the slope of EB was 1, and so the negative inverse of that would be -1. So I got -1x plus b. My x and y values are coming from C, and that's at 0, 6. So x, or 0 in for x and 6 in for y. You wind up with b equals 6. Oops. And so you actually can see that right here. And so anyhow, you get y equals -x plus 6. Y-intercept is 6, and then down 1 to the right 1. And you can see that line also would give us the orthocenter here at 1, 5. All right, indirect proofs. You got a couple different versions here. This one, you've been given your little equation with x and y and told that x does not equal 5. You want to prove that y does not equal 2. Well, after the given, you're going to go ahead and assume temporarily that y does equal 2. That's the negation. And then because you're saying that y equals 2, you can plug that right in here using substitution and solve for x. So I went ahead and just divided both sides by 2. If you did the distributive property, that's okay. At this point, I got 4x plus 2 equals 22 using the division property of equality. I subtract the 2 from both sides, that's the subtraction property of equality. I divide by 4, that's the division property of equality. I wound up with x equals 5. However, up here I said that x does equal 5. So you can't not equal 5 and not equal 5 at the same time. That's a contradiction. Sorry, I should have made that not equal to 5 like I did up here. And, well, that means that since the opposite is false, the original must be true. So y cannot equal 2, and that's a proof by contradiction. Over here, you've got a geometry version of proof by contradiction, or an indirect proof. You've been given that angle 1 is not congruent to angle 2. You want to prove that A is not parallel to B. Well, so you got the given, and now you're going to do the negation. You're going to assume that A is parallel to B. Well, if A is parallel to B, then angle 1 is congruent to angle 2, because these are alternate interior angles, and alternate interior angles are congruent when you've got parallel lines cut by a transversal. This is a contradiction. You cannot be congruent to 2 and not congruent to 2 at the same time. And so the original thing must be true. All right, sliding over here to the last section. Learning target 9, just use the triangle inequality theorem to see if these do, in fact, possibly make a right triangle, or not a right triangle, but just a triangle at all. And, well, I go ahead and find the sum of each of them. They're greater than the third in all 3 cases, and so, yes. Over here, I'd have to use the triangle sum theorem to find this third angle. And then once I have that, well, it's no problem to just say, all right, well, my shortest side should be opposite the smallest angle. Smallest angle is here, so that's the smallest side, BC. 41 is the next smallest angle, so AC is opposite of 41, so that's why it's the next one, and then obviously AB is the last one because it's the biggest. You can also clearly tell that, well, this is not drawn to scale, so count on that. Let's see, use the triangle inequality theorem to find a range for possible lengths of a third side. Well, here you've got 12 and 21, so either your mystery side is the longest thing, in which case 12 plus 21 would still have to be greater than x, or 21 is your longest one. 12 clearly can't be your longest side. It's already beat out by 21. So either 21 is your longest one, in which case 12 plus your mystery side would still have to be greater than 21. You do your quick little algebra here, and you get x has got to be greater than 9, and x has to be less than 33. And so you put it together in your compound inequality here. All right, so your problem-solving question, one very, very similar to what we did in our problem-solving days this unit. Kennedy is planning a city, and she wants the park to be of equal distance from the 3 things, the police station, the fire station, and the hospital. So here you've got those 3 things, and so tell her where she should build the park and how far away the park will be from each of these 3 locations. Well, to be equal distance from the 3 points here, you're going to want to find the circumcenter. The circumcenter, remember, that gives us the circumscribed circle, in which case all 3 points of the triangle would be of equal distance away. That would be the point of concurrency for the perpendicular bisectors. And so I draw a couple of perpendicular bisectors, which is easy to do since these are horizontal and vertical lines. And I wind up with a point here at 4.5. Unfortunately, it was not like right there on it for you. So half the distance between 8 and 1 is 7, and half of 7 is 3.5, and you're up 1, so it'd be 4.5. So some of you put 4.5. In which case you probably got most of the credit because that's kind of a sneaky thing. But anyhow, Kennedy should definitely put her park at the point 4.5 because that's going to be the circumcenter And then we just use the distance formula to find out how far it's going to be. You can use this as one point and well, any one of these three as the other point. And so I believe I used the police station. And I got about 4.7. So it's about 4.7 miles from each of these things. All right, that finishes off your review for Chapter 5. Good luck on your